All right, so the last question on this review topics SAT prep assignment is this one about left and right-handedness. This table is incomplete. They give us enough information to figure out the missing values in this table, and it's just a data table. It's telling us at this school, let's see, it's the 8th grade class, I think. Yeah, the 8th grade class at this Keisel Middle School has a certain number of right-handed female students, a certain number of left-handed female students, a certain number of right-handed male students, and a certain number of left-handed male students. We are going to grab a student at random, and we want to know the likelihood, this is at the end here, we're going to grab a right-handed student at random, and we want to know the likelihood that that student is female. So really, we just need to know out of these 122 students, how many are female and how many are male, because that's going to be the percentage that's the answer. Now, to do that, we have to go back and decode all of this. And when I solved this the first time, I got really bogged down in trying to fill out the whole table, and then I realized I didn't actually need to fill out the whole table. We don't need to know how many, I think, we'll see as we finish here. We don't need to know how many students are left-handed broken down by gender. Okay, so there are 5 times as many right-handed female students as there are left-handed female students. So this is getting into the other topic a little bit. The other topic that y'all really struggled on are the questions where there's a lot of words. And several of you called that out in the discussion board, which is awesome. You're spot on. Those are the harder questions for you guys. When I'm feeling confused, and I'm feeling confused right now as I try to make sense of what this problem is telling me, I go immediately to translate it into math. So as soon as my brain starts going, what? I go, okay, wait, there are 5 times as many right-handed female students as there are left-handed female students. We're going to assign a variable to each of these boxes. And I think I'm just going to go with A, B, C, D, and I'm going to draw them on there, and you can do this in your scratch paper so that I can keep track. So A, B, C, and D. This now allows me to treat these numbers as numbers that I know, because I'm going to just use the variables and do the math about them. So let's translate this sentence. There are 5 times as many right-handed female students as there are left-handed female students. So that means if we multiplied the number of left-handed female students, which is A, we multiplied A by 5, it would equal B. Right? So like just saying 5 times as many is tricky to translate it. It's not 5B. That's what we want to go to because B is already the bigger number. B is 5 times as many as A. So when we write this as an equation, it's like that. B equals 5A. All right, so next bit. There are 9 times as many right-handed male students as there are left-handed male students. We've done this once, should be decent to go again. 9 times as many right-handed male students, so D. D is 9 times as many as C. I think the hard part here is that the 9 times is written next to D, right-handed male students. But mathematically it does not go there because we're trying to write an equality. And so when I said it out loud just now, I swapped that around. I said D, right-handed male students, is 9 times as many as C. And that is exactly the order we're going to write it in for math. D, right? I swap out right-handed male students for D. I swap out is for equals. And I swap out left-handed male students for C, and I put in the 9 times. Cool, we are getting somewhere. All right, So now we're going to use this sentence to write another equation. 18 left-handed students and 122 right-handed students. Well, those we can get a sum out of. The total, because apparently there's no non-binary students in this school, the total left-handed students are A plus C. Left-handed females, left-handed males add up to 18. So we just look at the chart, use what we know, and make that into a sentence. A plus C equals 18. And then we do the same thing again for right-handedness. B plus D equals 122. Now, this is where I think we can cut out a step. We don't need to know A and C. We just don't. Remember, I drew this box at the beginning. We need to know B and D. So let's use this, but we might need A and C in order to find it out. Yeah, okay, we might have to solve the whole system. Okay, let's go. So, we're gonna simplify a pair of these equations down. We're gonna rewrite them as others. And we want to get more numbers in here instead of variables. Let's start with B plus D. So, specifically B, I want to know B. Yeah, I don't know if I'm doing the most useful step first, but so B plus D equals 122. Well, I can subtract D from both sides and say B equals 122 minus D, right? Once we know how many right-handed female students there are, that will be the same thing as the total minus right-handed male students. So now we have an alternate name for B. We can put it in there. That's not super helpful, is it? Maybe I want to do it this way. Okay, does that help? So I have a definition for B and a definition for D, and I have an equation that adds up B and D. So B is 5A, and D is 9C, and that equals 122. Okay, yeah. Okay, so one of the ways to solve a system of equations, which I now have set up here, is as long as you have two that have the same two variables, I need to get them to balance each other out when I add them up. I want one of my variables to disappear. So what I'm going to do is multiply this second equation, and I'm allowed to do this because I'm doing the same thing to both sides. I'm going to multiply each side by -5. And it's going to go to all of it. So that looks like -5a minus 5c equals 18 times -5. -90. Okay. Now we add that with our original 5a plus 9c equals 122. We're just going to add these up like it's a giant addition problem. We're allowed to do this because we're doing the same thing to both sides. It might look different, but we know the truth that these are equal numbers. Once we know what A and C are, they will add up to 122. So we are now adding the same thing to both sides in a way that will cancel out 5a. Minus 5a plus 5a balances out. We're left with 4c equals 122 minus 90. So 32. That solves beautifully. Divide both sides by 4. C equals 4. 8. C equals 8. Okay, so that's not a number that we need, but can it help us get it? C and D, do we have any equations with those in it? No, we don't. C and A. Yes, we do. Okay, so if C is 8, A is 10. Right, I got that by subtracting 8 from both sides, now that I know C is 8. And do we have, okay, B is 5A. Now we're getting somewhere because we want to know B. 5 times 10, 50. I think we now know enough to solve this problem because we're being asked. Right. Well, and of course, B plus D makes 122, so 122 minus 50. 72. We've now solved the whole table. And we are picking a right-handed student at random, so a student out of these 122. We want to know how likely it is that student is female, so it's 50 chances out of 122. We're going to probability, right? The rule for making a probability is what are the total possible results? That's 122 right-handed students. What are the desired? That's the 50 female right-handed students. So we make it a fraction. Desired over possible. And this goes to the calculator. .4098. That's this one. Okay, so what did we do here? We translated the information they gave us into sentences. Well, we assigned variables. So I know I put this here under review because the topic is technically probability, but I think if they'd given you the table with 10, 8, 50, and 72 in it, you would have been able to get this way more often. And what was actually the problem is that this is a giant and intimidating and messy 4-equation system that you have to not only solve, but write. So if you want more review on this topic, look up systems of equations. And there will be plenty of YouTube videos that'll help with that. Good luck.